Hi, I'll start off. I'm Mike Tougeron. I'm a senior site reliability engineer at Adobe. I've been using Kubernetes since 2015-ish, mid there.
I'm Vladamir Vivien from VMware. I'm a software engineer working upstream on Kubernetes, specifically storage. I like Go, the programming language, and have been known to write a couple books about the subject. So hopefully we'll get something on the screen. If not, I'm going to go off memory. Let's see. Yeah, I mean, we pretty much just did that. Let's go to the one before that. Sorry, we broke the whole thing.
I don't know what happened. Really?
I told my boss there'd be no way I'd be sick for today. I think this is even better.
All right. Oh, cool.
Okay, so just forward them manually.
All right, yep, that'll work. So we just did the introduction. I'm Vladimir.
Oh, I'm Mike.
Mike, all right, so we can skip the formalities here. Let's see. Sorry. Trying to see the screen.
You know what, this all can come down here.
Oh, yeah, well, that works even better. All right.
And, oops.
That's fine.
Aren't you proud of me that I had a backup plan?
Yeah.
Awesome.
All right. So it's best practices for deploying stateful applications. So what are we talking about? The abstract of what we want to talk about is we have modern applications that are running on Kubernetes, and usually they're dubbed stateless. And we'll talk about whether we truly have stateless or not. But these applications usually, they maximize portability and scalability across your clusters. But at the same time, we have another set of applications that are dubbed stateful. And these classes of applications usually are your databases, your messaging systems, and your searches, et cetera. Those type of applications usually require your binaries to be co-located and running with your data. So what we want to do is to highlight the primitives that are available in Kubernetes to help you get to those stateful applications. And for quickly down the agenda, we're going to go over the motivation for statefulness. What are the stateful applications on Kubernetes? Building blocks to get to statefulness. And then I'll switch to Mike, and we'll talk about actual use cases that use those primitives to get to statefulness. So I'm going to start by making a bold statement. There are really no stateless applications. And you may say, well, I've always heard about stateless applications. What do you mean, Vladimir? What I mean is, what we do have are applications that have data in different localities and access constraints. That's really what we're talking about. But we'll use the stateless and stateful moniker because we're used to them. So traditional stateless workload usually are business-related processes, and their long-lived data is usually outside of the application itself, and you have something like a database or an API endpoint, a streaming platform of some sort for the data. And even for those applications, even when they are using files, those files are usually ephemeral and they come and go with the pod. Those data points, sometimes they are on Kubernetes and oftentimes they're outside of Kubernetes. And what does that allow you to do? So as your application is running on Kubernetes and the scheduler is moving things around, your applications can land from one node to another without having any issue. So it's unbounded. It can move from node to node without your application having crashing. But however, as we'll see, there are types of applications, as I mentioned earlier, that requires access to data that are closer and will use the OS itself to access that data. Now, those are usually called stateful applications, right? And They can be business-related workload, but a lot of time they're what we're calling infrastructural applications. They're your databases, streaming platform, search indexing, etc. For these applications, we want the long-lived data to be on a file system somewhere, or a block system even, and a lot of times we'll require OS calls to access that data. Now, once you get to statefulness, things get a little bit more complicated. For one, your file system is owned by the OS, so you can't just pick up and go from one node to another. So if the scheduler happened to reschedule your application from one node to another, things might go south real quick. So you have more constraints for portability. Excuse me. Pods need to access data from the original volume. That original volume, once the pod is moved, may not be there. Data may not exist from on the new pod, or worse, you may get your application may get scheduled somewhere where that volume existed and start overriding existing data and cause even worse problem with data corruption. So stateful apps are difficult because state have meaning. Your application and the state that it creates usually have one-to-one mapping. So your instance for your application need its states that it originally created or started to consume. We have resiliency issues with stateful applications, and a resource contention can creep up real quick and start degrading performance, etc. Now, what are available in Kubernetes? One of the things that we have in Kubernetes are storage primitives. So we have files and block storage. They're available from different vendors listed on the screen, the logos, which is not by any means an exhaustive list. And those providers use Kubernetes application abstractions to expose data to running applications using things such as storage classes, persistent volume, and persistent volume claims. We're not going to go deep into what these are, but these are abstractions that provide a uniform API for your application to consume data on a Kubernetes platform. Now, the other thing that we want when we want to get to statefulness is we want to kind of quiet down the scheduling noise that can happen during the course of your application, and you want to make things more predictable. And one of the things that you can use to do that are stateful sets. And stateful sets give you stable identifiers for your pod, so your pods won't have different names as they come up. The stable persistence, because you want your pod to come up and possibly get, or not possibly, but you want them to be scheduled on a node that has the data that it needs and not somewhere that doesn't have the data that it needs. And you also want ordered operations to happen, because you may have an application and database running. You might want the database to come up first, or your application may crash if the database is not available yet. So I'll stop here because I'm going to give Mike the mic so he can continue and talk more about StatefulSet and how he uses it with Elasticsearch for an actual deployment, production deployment.
Great, thanks a lot, Vlad.
Sure.
So as he mentioned, I'm Mike, and here. So before we get started into our use case, one of the things I think is important is to take a step back from just moving a VM into Kubernetes as a stateful application. You got to step back and think about what your application is. How is it used? How do other services interact with it? Because it may not be the same way. Does your application need fixed host names to get into it, like you want a Zookeeper client to? Or is it going to be something like a MySQL replication group of those where it's just service discovery or simply load balanced amongst them? And then you got to start thinking about how your application utilizes its data, its state. Is it a shared system, Memcache, Redis, that sort of thing? Or is it going to be saving it to the file system? In the case of Elasticsearch, you have sharding, so it's going to shard it across the different data nodes. MySQL replicates it from the master. These things are solved, easy problems in the VM and bare metal world, but as you get into a stateful application inside of a containerized system, inside of Kubernetes, they work a little bit differently, and it's very easy to overlook solved problems that don't work quite the same way. So as Ron says, scheduling is a big deal. Vlad had mentioned the ordered deployments. Updates and deletions happen the same way. So it'll do the first one, wait till it's ready, second, so on. Deletions work in the reverse order. One of the nice things with deletions, it will keep your persistent volume claims. So you're not like you're going to lose your data if you scale it down. For something like Elasticsearch, your pod management policy being ordered, going from 0 to 1 to 2 in order makes a difference. But for MySQL replication farm, you can just do parallel, spin them all up. It's nice and easy to do. If you're like me, canary deployments are a big deal. Blue-green deployments, hopefully you're able to utilize those and not, break production because you shipped it out everywhere. You got that option with inside StatefulSets inside of Kubernetes. One of the things that we found really helpful in hindsight is the post-start, pre-stop options for containers. I don't know if, show of hands real quick, if who's familiar with those. Well, about half the room. So those are really good for registering your applications in and out of a clustered system. And we're going to go into our use case and why those to me made a big difference in what we were doing. But the last statement down here is it's a little redundant from this room with everybody using it. But for more junior people, I find a lot of times people think a stateful set means it's always going to be running in Kubernetes. And it's always good to call out that it's not always running. It's going to be rescheduled. It just means that your application has state and you're telling Kubernetes that it has state. Some storage considerations as we step back again. In a CSI world, storage classes can be a little bit different. We're going to talk about CSIs later today. I think it's the next talk. But what does your backend allow? Are you using an EBS volume in Amazon where it works in one AZ? And if that goes down, is your stateful application going to run in another AZ, or is your data lost? So your failure domains may be a little bit different than what you're used to. If you, like Vlad mentioned, you're writing on a single host, it's very easy in a VM, I'm rebooting that host, or I'm just going to image that host, push it somewhere else. If your application is rescheduled, that's not going to be what happens. So our use case today is Elasticsearch. The important things you'll see up there, ES data is a stateful set. That's our data nodes, our data pods. Those are backed by persistent volumes. And ES master are our Elasticsearch master nodes. Those are also a stateful set. And then ES client is kind of your query or ingest where data comes into the cluster. Quick show of hands, who's familiar with Elasticsearch? Okay, so everybody's got this down. We're using FluentD for collecting and Kibana for querying. So real quick, to explain some of our use cases, it's important to know what our system is. The most important thing in here to recognize is we have a lot of machine learning workloads inside of our AWS cluster. It causes a lot of scaling up and down, so our size of the cluster varies quite frequently. Combine that with our deployment process being a baked golden image AMI, that when we make a configuration update to Kubernetes, we bake the new AMI with Packer, and then we cycle all the nodes until the new stuff comes up. And so with the auto scaling in that means that the nodes that are running today are probably only some of the nodes that are running tomorrow, which are definitely not the nodes that are running in January. So there's a lot of volatility to our cluster. This works really well for us for a variety of reasons, especially with the ML jobs. We get a lot of cost savings by scaling down and only scaling up when needed. But it's caused some problems for us. First one, oops, our crash loop backoffs. So this wasn't a problem with Elasticsearch per se, this was an issue with our deployment process. We were not properly respecting our pod disruption budgets. So if you're an operator, stateful applications, that disruption budget is a big deal. You don't want to just disrespect it, start killing stuff, and all of a sudden stateful applications can't handle their state changing. One of the things we did to solve this problem was we started, if we had, let's just say 5 nodes up, we would cordon those 5 nodes, double the size of the cluster, start draining over to the new one that already have the new AMI baked into it. As you do larger sizes with that, disable your autoscaler. That was kind of a pain, that deployment. We scaled up to 50 nodes. The autoscaler scaled us back down to 20 something. So that whole process caused a lot of trouble for us. So in the graphic before, you saw that I said the master nodes are stateful sets. Here you'll see that they're deployments. This was also part of our problem because data loss. Nobody likes data loss. Elasticsearch is a clustered system, so it's a stateful application, but quorum matters. So if you lose your quorum, you can lose your data. One of the things you'll see up here, I mean, you've probably seen this before, state is red, and our data percentage is only 93%. So we lost 7% of our data in this scenario. These were basically, we didn't follow best practices with configurations of Kubernetes, or not Kubernetes, Elasticsearch. When we ran them as VMs, all this stuff was just kind of in place, Puppet or Chef or whatever, just configured these things as we went. But what we did was we followed the blog. Made a lot of sense. I see you laughing over there, right? Made a lot of sense. Matched up to what we were doing in the VM world. Worked great when we first put it up, but it didn't handle edge cases. It didn't notify the Elasticsearch API when things came up or went away. So then now we're at the pre-stop, post-start. Data node comes up, tells Elasticsearch, hey, I can be a primary. Goes away, hey, I am not primary anymore. Make somebody else that way. And that solved a lot of our data loss issues. We set more appropriate pod disruption budgets. These are important for stateful applications. I mentioned that briefly before. But now instead of just saying, oh no, only do one master at a time, we set a min master of 2 being available, so we never lost quorum. That is losing quorum and split brains. I hate that. So a lot of this came from we're switching to Helm charts. It's one of the benefits of Helm charts and operators that are out there for these stateful applications is that they follow the best practices defined by either the code maintainers, the application creators, or the community around it that has been running these at scale and have those best practices. They take into account these edge cases where if you take away your data nodes too quick, all of a sudden things kind of go foobar and sideways on you. So in the Helm charts, we saw, oh, hey, yeah, use pre-stop, post-start. That worked out great for us. Not saying Helm charts are the right way to go, operators are the right way to go. It's different for every person, what works well for you, but following those community best practices make a big difference. So here's a few options you have out there with Helm charts, operators, stateful sets. Cassandra Kafka is going gangbusters from everything I hear in Kubernetes. A lot of people are doing that now very successfully. Vlad, you were telling me that the operator for Kafka works very well. So use these, follow best practices, and your stateful applications can work really well. A lot of these problems we ran into were in our very early days, and now we're running them using these best practices, and we're really happy with the way in which it's working. You want to add? All right. Any questions about running this stuff from the audience? Or from the audience about running this? All right. Well, thank you very much.